Assalamualaikum warahmatullahi wabarakatuh. I am from Group B5 and today I am going to present about software construction. So let's begin. Okay, for software construction, we are going to learn about constructing the code, minimizing complexity, anticipating change, constructing for verification, reuse, and standard in software construction. Okay, for the introduction, what is software construction? The term software construction refers to the detailed creation of working software through a combination of coding, verification, unit testing, integration testing, and debugging. After that, software construction is also closely tied to software design and software testing. This is because before software construction, a design is extremely important, so that way we can figure out whether the system can actually satisfy the client's need, and we can also figure out the flow of the system. So after the construction, a testing is also very important, so that way we can see whether the system is actually excelling or whether it's actually failing. Okay, what does software construction produce? Software construction typically produces the highest number of configuration items that need to be managed in a software project. For example, source files, documentation, test cases, and so on. Thus, the software construction is also closely linked to the software configuration management. Okay, construction in software construction. Software construction is tool intensive. This is because these tools are used to produce and translate program representation, for instance, source code, which is sufficiently detailed and explicit to enable machine execution. Okay, why does construction highly related to computer science instead of information technology, IT? Well, this is because of the use of algorithm and the detailed coding practices, while IT mainly uses the problem-solving skills. Okay, so for the code construction, we have two languages, C++ and Java. So on the left side, we can see there's a diagram, a student diagram. Inside it, there are 4 variables and 2 methods. On the right side, we can first see the code construction for C++, and this is the code construction for Java. Okay, moving on. The minimizing complex. Human brains are limited to hold complex information, therefore, minimizing complexity is one of the strongest drivers in software construction. It is necessary to reduce the complexity throughout the life cycle, so that way we can make the workload a lot more efficient. However, as functionality increases, so does complexity, since during the construction of a system, it is very normal for the clients to add some requests, therefore increases the functionality. Luckily, things can be accomplished through use of standards. For example, J2EE for complex distributed Java applications, YAML for modeling all aspects of complex system, high-order programming languages such as C++ and Java, source code formatting rules to aid readability. Okay, anticipating change. Software changes over time. Anticipation of change affects how software is constructed. This can affect the use of control structures, handling of errors, source code organization, code documentation, and coding standards. Okay, after that, constructing for verification. Constructing software that allows bugs to be easily found and fixed. For example, enforce coding standards, helps support code reviews, unit testing, organizing code to support automated testing, restricted use of complex language structures. Okay, after that, for reuse, refer to the use of existing software or software knowledge to build new software or solving different problems. Assets that can be reused include libraries, modules, components, source code, and commercial off-the-shelf COTS assets. Best practice, systematically, according to a well-defined repeatable process. Systematic reuse can enable significant software productivity, quality, and cost improvements. The standards in construction. The standards which directly affect construction issues include programming languages, example given, Java and C++, communication methods, document formats and contents, platforms, J2EE, Java 2 Platform, Enterprise Edition. And lastly, tools. The unified modeling language, UML. And that's it from me. I will pass the presentation to another presenter. Thank you.
Why do we need to learn coding standard? It is to ease software maintenance, less bug, for teamwork, make it easier for team switching, and save costs. For the types of coding standard, the first one is by company, and second one is by programming language. There are several common practices for coding standard. The first one is identations. It is to identify scope in some programming languages for the compiler. It is to show the indentation of functions, objects, and other else. Below is the example of line of coding without indentations and with indentation. Next is commenting code. Comments should clearly demonstrate the function of the code, both to yourself and to other developers, to help them understand the function of the code. The comments should not too long. Comments should not be in every line, exceptions for functional languages, and it also should not be overcomplicated. The third common practice of coding standard is white space. It is very important but often overlooked. White space makes the code easier to read, especially important with large programs. Lack of white space can be very confusing. This is an example line of coding with white space and without white space. The last common practice of coding standard is naming variables. Variable names are often thought to be less important, but they are vital to understanding certain pieces of code. In the majority of programming languages, variables can be assigned almost any name. Greenfield versus brownfield development. Greenfield development is when the software project starts fresh without any legacy system constraints or restrictions. Brownfield development is when the software project starts on existing or legacy system and infrastructure as an upgrade. The advantages of greenfield development is provide maximum design flexibility to meet requirements. New facility will reduce required maintenance and can be designed to meet current and future needs. The disadvantage is some systems are not fully developed and have additional development costs. Second one, stakeholder approval timeframes may be longer for new software project. And the last disadvantage is it is high demand of a new software system could mean the delivery of the system is difficult or even impossible to meet. The advantages of brownfield developments, it may include existing stakeholders' approval. Second one, existing system infrastructure may already be in place. The third one, total project may cost less, but depends on how extensive the modifications are and whether existing system can be utilized without major modification. The disadvantages, design and operation efficiency is often compromised to suit existing constraints, and the legacy system can be rigid design and not meet new requirement, which is higher risk of new development, and enhancements may be difficult due to make. That's all from us. Thank you.